Hi everyone, this is Tom Newth with Nozomi Networks, and today we'll be discussing the topic of hybrid ICS threat detection. What is it and why is it so important? Now, before we get into the specifics as what constitutes a hybrid approach to threat detection, let's examine the anatomy of a malware attack using InDestroyer, or as it's otherwise known, Crash Override, as an example. Now, InDestroyer just recently, as the summer of 2017, downed the grid in Kiev as a response to the invasion of the Crimean Peninsula, and then spread globally to affect everything from transportation networks to manufacturing facilities, especially in Asia and Europe. So it's a big deal. Now, InDestroyer can be distilled into three basic phases of an attack: an infection phase, a discovery phase, and the ultimate attack phase when it runs tailored attacks to gain access and control to system components, gather sensitive information, or disrupt or shut down operations, thus putting you on the headline of the front page of the newspaper under the title Cyber Attack Where You Don't Want to Be. So how can you assess if an ICS cybersecurity solution out there has a hybrid ICS threat detection component to it? And how can you actually assess how robust and comprehensive that threat detection suite is? Well, first and foremost, you want to evaluate their ability to conduct anomaly detection. It's not enough to simply say that you have anomaly detection. It needs to be tested in a POC format because anomaly detection is relevant across all phases of a would-be InDestroyer attack. Now, Nozomi Networks has what we call a behavior-based anomaly detection capability that's enriched with AI and comes with an analytics engine that not only allows us to identify anomalies in communication structure and data flow, but also correlate and test that correlation with covariance across various incidents and identified anomalies. In other words, if you have a geo-distributed network or expansive plant or network of operations, you're going to have various alerts or incidents that might have an underlying cause. In this case, it could be InDestroyer. And you wouldn't otherwise know that if you did not have a comprehensive anomaly detection capability. Now, behavior-based anomaly detection allows you to quickly uncover if there is an existing underlying cause between a certain portion of many alerts, allowing you to quickly remediate the issue in near real time, which is definitely critical. In addition to behavior-based anomaly detection, we have what we call rules-based analysis. Now, rules-based analysis speaks to a solution's ability to basically support proactive threat hunting. Now, proactive threat hunting can be achieved in two various ways: via external rules-based analysis or internal rules-based analysis. Now, in the case of Nozomi Networks, we offer things like YAR rules and packet rules. Now, YAR rules is an external third-party database that's updated by experts and IT researchers within the security field of known malware profiles and attacks. You're basically able to capitalize on this continuously updated database of knowledge experts and integrate it into the Nozomi Networks ICS threat detection suite. So it's very useful. And in addition to this, it examines entire file sets, not just packets. Packet rules are very similar to YAR rules, in fact, in the sense that they are a third-party rules-based analysis resource, but the difference is in the name, where rather than identifying and examining complete file sets, they examine packets. Now that brings us to the assertions component, or the proprietary rules-based analysis component. Nozomi Networks SCADA Guardian has a rich analysis toolkit that comes with various assertions out of box, ready for the user to execute on if required. But in addition to the analysis toolkit, we also offer a query engine so you can quickly create your own custom assertions according to regulatory or industrial or even specific organizational need. So this multi-tiered approach to threat detection is what we call hybrid ICS detection. And it's very important in allowing you to quickly extend the capabilities of conventional IT cybersecurity. In other words, you have a SIEM, you have a firewall, you have a industrial firewall, and you have apt design of industrial networks using redundancy and subnetting. However, this will only mitigate damage and only address known knowns in the case of SIEMs and firewalls. What happens when you start opening up your network to things like remote access or cloud SCADA, or basically increased connectivity of your industrial systems with MES, for example? You expose your network to threats that SIEMs, firewalls, or industrial firewalls can't stop. Now, using a solution like SCADA Guardian and a hybrid ICS threat detection approach, you can passively monitor network communication flows, identify anomalies, and therefore identify threats with context and quickly narrow in on the applications and nodes they're affecting. Now, what does this look like in terms of a use case perspective from our vantage point? Well, thanks to anomaly detection, all deviations from a baseline can be alerted at different levels. A new incident, for example, is identified with context. A new communication is detected in this circumstance with an associated risk rating. You're able to quickly open up those incident details and draw even more details and context. In this case, a rogue MAC address is identified. A new Modbus connection is detected, and a Modbus reprogram command is detected. And a PCAP, or packet capture, is taken prior to, the moment of, and the moment following the event for post-mortem or forensic analysis or reporting needs. Now, that concludes our short explainer video on hybrid ICS threat detection and why it's important. For more information on hybrid ICS threat detection, as well as real-time visibility and asset inventories, and more about the Nozomi Network solution, please go to nozominetworks.com. Once again, this is Tom Knuth from Nozomi Networks, signing off. Thank you.